Right, welcome back. Now we're doing addition and subtraction of exponents. So when we do addition and subtraction of exponents, it's very similar to multiplication and division, but the only thing here is that here we will do factorization. So let's start. So step number 1, it says you show that 2 to the power of x plus 1 plus 3 times 2 to the power of x is equal to 5 2 times 2 to the power of x. So we need to prove that this side here is equal to that side there. So we only work on these two terms. So step number 1, prime factorize. It's already done. Step number 2, multiply out the exponents. It's already done. Step number 3, if it's addition, if it's multiplication and division, then follow the rules from step number 3 of the previous video. But here it's addition. So here we need to go and separate the terms. So we're going to say 2 to the power of x times 2 to the power of 1 is the same as this, plus 3 to the power of 1 times 2 to the power of x. Right, once I get something like this, I say, right, I need to take out a highest common factor. When I take out a highest common factor, say what is common here, what is common there? It's 2 to the power of x. When I take it out here, I'm left with 2 to the power of 1. When I take it out there, I'm left with 3 to the power of 1. Then finally, I said, right, so 2 to the power of x, 2 plus 3 is 5. So this is the same as 5 times 2 to the power of x. So therefore, my left hand side is equal to my right hand side. That's very simple. Right, so it's the only difference between this one and multiplication division is here we do factorization. So the next question says number 2. So it says simplify 9 to the power of x minus 1 plus 3 to the power of 2x. So when it means simplify, it means the exact same thing as always. So step number 1, prime factorize. So we prime factorize when I say equal to 3 to the power of 2 open brackets x minus 1 plus 3 to the power of 2 to the power of x. Right, so that basically can't prime factorize. But now what's the step number 2? Exponents on the inside, exponents on the outside, multiply. So 2 times x, 2 times negative 1 is negative 2 plus 3 to the power of 2x. Once we come to this part here, now when we come here, this is the part where you have to say, is it multiplication and division or is it addition and subtraction? Because it's addition and subtraction, we need to separate the exponents, or separate the terms. So 2 to the power of x times 3 to the power of negative 2 plus 3 to the power of 2x. When we separate them, because we separate them, we are able to see what is common, and we see what is common here is 3 to the power of 2x, and what we are left here is 3 to the power of negative 2, and if I take this and divide it by that, I'm left with a number 1. This doesn't disappear. That's where many people make a mistake. And then now if I type this into my calculator, I get it to be 1 over 9 plus 9, which is 10 over 9. So therefore I get 3 to the power of 2x open brackets 10 over 9. Now remember, in grade 11, grade 10, 11, 12, you get weird numbers or weird answers, and this is a weird answer, so therefore it's correct. It's fine, don't stress, your answer is correct. Now we're going to do now we're going to do ones where we have denominators that have both of these things happening at the same time. Right, so now we're going to do with denominators that are also part of it. Right, so let's see, hopefully it will fit. It will fit here. Well, let me just use a new page, okay? So here it says simplify this expression. So number 3, simplify this expression. So 3 to the power of x plus 2 minus 3 to the power of x all over 3 to the power of x plus 1 minus 3 to the power of x minus 2. So step number 1, prime factorize. Right, so it's already prime factorized. Step number 2, multiply your exponents on the inside with exponents on the outside. This is already done for us. Step number 3, identify, is it multiplication and division, or is it addition or subtraction? This is addition and subtraction occurring. So here it's subtraction in the middle between see, here's a subtraction sign, here's a subtraction sign. If it had dots, that would have mean it's multiplication. So we need to separate the terms. So 3 to the power of x times 3 to the power of 2 minus 3 to the power of x all over 3 to the power of x times 3 to the power of 1 minus 3 to the power of x times 3 to the power of negative 2. Once you come to this step here, now you need to factorize. So when you factorize your numerator, you factorize your denominator. So you take out a common factor on the top. So 3 to the power of x, if I take it out, I'm left with 3 to the power of 2 minus 1. That's very important. You must remember 3 to the power of x divided by 3 to the power of x is 1. Then at the bottom, what do we have common in the bottom? I also have the exact same thing. So 3 to the power of x, and then I'm going to open here 3 to the power of 1 minus 3 to the power of negative 2 equal to. Now, when I have something like this, I can see that they are like terms. So because they are like terms, 3 to the power of x and 3 to the power of x here, I can cancel it out. Because remember, only multiplication is correct. This is being multiplied by that. This is being multiplied by that. You can only cancel out when it's multiplication occurring. So this goes here once, this goes there once. I'm left with 3 to the power of 2 minus 1 all over 3 minus 3 to the power of negative 2. If I had to type this out in my calculator, or if I had to do it without a calculator, I would have said 8, because 9 minus 1 is 8, over 3 minus 1 over 9 is equal, I typed my calculator, 36 over 13. And that's my final answer. I could make it into a mixed number, but it's not necessary. Now let's do the next one. The next one is exactly the same thing. We follow the same exact concepts, right? So we're going to say here number 4, let's say 3 to the power of 2x minus 1 all over 3 to the power of x plus 1, right? When you come to something like this, right, so step number 1, prime factorize. We can't prime factorize, it's already done for us. Step number 2, multiply exponents on the inside and outside, it's already done for us. Step number 3, identify if it's addition, if it's multiplication, division, or addition and subtraction. Here it's addition and subtraction, so we need to separate the terms, but the terms are already separated for us, so we need to factorize. Now normally when we factorize, we find the highest common factor, but here we can't find the highest common factor because here there's no highest common factor and here there is no highest common factor. Now when you come to something like this, I could rewrite this out in a different way. I could rewrite this to be 3 to the power of x all to the power of 2 minus 1 all over 3 to the power of x plus 1. Now remember, when you factorize, you do highest common factor, then you need to identify, is it a difference of 2 squares, is it a trinomial, is it completing a square, is it etc etc. So like you see here, this is a square, this is a minus 1, 1 is also a square, and we have a minus sign in between. Because there's a minus sign in between, I can do the difference of 2 squares. So I can basically open a bracket and say 3 to the power of x minus 1, open brackets 3 to the power of x plus 1, difference of 2 squares, and 3 to the power of x plus 1. I can make this into a bracket also. So now what do? I have like terms. So if this whole bracket goes here once, this whole bracket goes there once, and I'm left with my answer 3 to the power of x minus 1. Very simple, hey? Right. Now we are going to give you examples and you have to try it out. Put yourself, let's see which examples can you do yourself now. Right, you are going to do this one here yourself. You're going to show the first one. You're going to simplify the second, third, and fourth and fifth one. So it's 2, 3, 4, and 5 are simplifying. Now something like this, I would give yourself, because it's 5 sums, I would give yourself 10 minutes to do them. So put your timer on for 10 minutes and you need to do it. Remember, you must pause. Please try the following on your own. You can do it. You must just believe, because you can do it. So put your timer on for 10 minutes and come back to this video afterwards to see if your answers are. Right, I just had a nice cup of tea. Now I'm gonna start. Okay, so step number 1, prime factorize. We don't need to prime factorize here. Step number 2, multiply the exponents on the inside, the exponents on the outside. Here we don't need to do that. Step number 3, see if it's addition or subtraction or multiplication and division. If it's multiplication and division, follow the steps from the previous video. If it's addition and subtraction, then you need to separate the terms. So now we're going to separate the terms. We're going to say 2 to the power of x times 2 to the power of 3 minus 2 to the power of x times 2 to the power of 2. Then step number 4, take out a highest common factor or factorize the expression. So 2 to the power of x is common on both sides. So 2 to the power of x, open brackets, divide 2 to the power of 3. You're left with this side, this divided by that, you're left with 2 to the power of 2. And then you're going to say, right, so you're going to say 2 to the power of x. Here it's subtraction. So when you're subtracting here, don't just say it's 3 minus 2 is 1. No, you can't do that. 2 to the power of 3 is 8. 2 to the power of 2 is 4. So it's not going to be 2 as my answer. It's going to be 2 to the power of x times, or in this bracket here, it's going to be 4, or 2 to the power of 2. So what is 4? 2 to the power of x times 2 to the power of 2, which is the same as saying 2 to the power of x plus 2. So it's equal to, therefore, my left hand side is equal to my right hand side. We completed that. Now the next one, again, step number 1, you're going to say, right, prime factorize. We're going to have to do that. Step number 2, multiply exponents on the inside, exponents on the outside. We don't have to do that. Step number 3, identify if it's addition or subtraction or multiplication division. It's addition or subtraction, so therefore we need to go and separate our terms. So 2 to the power of x times 2 to the power of 2 minus 2 to the power of x times 2 to the power of 3 all over 2 to the power of x times 2 to the power of 1 minus 2 to the power of x times 2 to the power of 2. Now once we come to this step here, now we see, okay, what can I do? Can I prime factorize? How do I prime factorize? I have to say what is common. So in the top, now you prime factorize your numerator, prime factorize, I meant to say factorize your numerator, factorize your denominator. So your top, x to the power, 2 to the power of x and 2 to the power of x is common, so I take it as a common factor. When I get rid of it, I'm left with only 2 to the power of 2 for the first one, and for the other one minus, I get left with 2 to the power of 3. And I say all over, what's common at the bottom? 2 to the power of x, I'm left with 2 to the power of 1 minus 2 to the power of 2. And then I say, okay, now because there's only multiplication occurring, I cancel out like terms, so this cancels out with this, and then I'm left with these numbers here. Now what I normally do is I like to go and type this in a calculator. I type out my numerator and I type out my denominator, and then I get my answer straight away from that. So I'm going to say 4 minus 8, so the top one is going to be 4 minus 8 all over 2 minus 4. Right, that's 2 minus 4. And then I'm going to get my answer here is negative 4 over negative 2, which is positive 2. So my final answer is a positive 2. Did you get that? I hope so. Right, let's recap again. Number 3, again, step number 1, prime factorize. So when I prime factorize, now I can prime factorize. So I'm going to say, what's the prime factorization of 9? It's 3 to the power of 2 all to the power of x. What's of this one here? This one here is already done for me, so I don't have to worry. But now if you have to do for 18, you have to be like, okay, what times what gives me 18? So we know for 18 it's going to be 3 to the power of 2 times 2 to the power of 1 all to the power of x, and then here is a multiplication sign, so it's 2 to the power of 1 minus x. Now this is a tricky one because it has addition and multiplication at the bottom, so we'll have to treat them differently, we'll treat them separately. So the top part, we're going to be like, right, what's happening on top here? So I'm going to multiply out, so 2 to the power of 2x plus 3 to the power of 2x plus 1. At the bottom, I'm going to multiply out also, right? I'm going to say times 2 to the 1 minus x. And then I'm going to be like, okay, because there's addition on the top part, I'm going to do factorizing of the top only. So what's common on top? 3 to the power of 2x. I'm going to have 3 to the power of 2x common on top. I'm going to take it out. I'm left with 1 plus. And then what am I left with here? I'm left with here, if I take out this divided by that, I'm left with 3 to the power of 1 all over 3 to the power of 2x times, now this I can already cancel out, the x minus the x cancels out each other, so you're only left with 2 to the power of 1 at the bottom. And then finally I'm going to say this goes here once, this goes here 1, I'm left with 1 plus 3 is 4 over 2, so 4 over 2, my answer is 2. No, your answer is not going to always be 2 and 2 all over the place. This just happened that these two sums gave me the same answers, but the method is still the same. Alright, so I hope you understood it. So let's recap in steps. Alright, let's continue now. So we have to do number 4 and number 5. So again, prime factorize, we don't need to do that. Multiply the exponents to the outside, don't need to do that. If it's a multiplication division, follow the previous video. If it's addition and subtraction, then separate the terms. This is already done for us. So now we're going to say, okay, what must I do here? Now here you can, oh yeah, the next step, factorize the numerator, factorize the denominator. Here it's x to the power of 2 to the power of 2x, and here 2 to the power of x. So 2 to the power of x is common here. So when I take away here, and I remember this is 2 to the power of x times 2 to the power of x. So let's separate it so you can understand. It means that minus 2 to the power of that all over 2 to the power of x minus 1. So now I got a common factor, I take it out. So when I take it out, I say 2 to the power of x. When I'm left here, I'm left with 2 to the power of x. When I'm left here is minus 1 all over 2 to the power of x minus 1. Now this whole thing at the bottom is the same as the top. I cancel out like terms, and my final answer is 2 to the power of x over 1, which is just 2 to the power of x. Then I have, let me just check if my answer is correct. Sometimes I'm so paranoid it's not correct. Yeah, it's right. Then I'm going to do the next one. So the next one is same type of thing, prime factorized. So prime factorized is 2 to the power of 4 minus 2 to the power of 2 all to the power of x. Here 2 to the power of x minus 2 to the power of 2. Then multiply the exponents on the inside and the outside. 2 to the power of 4 minus 2 to the power of 2x all over 2 to the power of x minus 2 to the power of 2. Then you need to say, right, is it addition and subtraction, is it multiplication, division? What do I need to do here? So in this case here, it's addition and subtraction, so I need to prime factorize. So when I go and prime factorize, I need to say, okay, what can I do here? I'm gonna be like, crap, this is like a hectic one. This looks like a difference of 2 squares, but the difference of 2 squares is gonna be a little bit crazy. So I'm gonna be like, okay, what can I do here? So I can say, right, difference of 2 squares, so 2 to the power of 2 minus, then this one here is going to become 2 to the power of x. This one here, 2 to the power of 2 plus 2 to the power of x. Now, all over 2 to the power of x minus 2 to the power of 2. Can you see this one here? It looks similar, but here the 2 to the power of x is negative, and here the 2 to the power of x is positive. So remember, when you want to swap around, when you make one becomes negative and other one become positive, then you need to take out a negative sign. You need to divide it by a negative 1. So if I take out a negative 1, then this bracket now swaps around. This becomes negative and this becomes positive. So 2 to the power of x minus 2 to the power of 2, 2 to the power of 2 plus 2 to the power of x, all over 2 to the power of x minus 2 to the power of 2. So this whole thing here is 1. So this goes here once, this goes here once. And my final answer is negative, open brackets, 2 to the power of 2 plus 2 to the power of x. But then I need to multiply it out. So my answer is negative 4, negative 2 to the power of x. That's my final answer. Right. So you must always follow the same steps over and over again. So the steps you're going to follow is the same thing here. When you're adding and subtracting of exponents, number 1, you need to prime factorize. Number 2, you need to multiply out the exponents. Number 3, if it's multiplication, division, you must follow the previous video. If it's addition and subtraction, you separate the exponents. Number 4, factorize the numerator and denominator. Example, find the highest common factor or the difference of squares. Number 5, cancel out like terms. And number 6, simplify fully. If you follow these steps, you will definitely get it right. And then we are done with number 2, video number 2. Right, take care and good luck. Okay, bye.